Welcome to week 3 start camera action. So the past week what we had seen was for the which way lay of the land. So we had seen different drafting settings, object snap, dynamic input settings, units, limit specification, and various editing fundamentals such as move, copy, array, break, mirror, offsetting. So with this, you also had a hands-on experiment on assignment 2 that would have given you a great clarity on the various editing fundamentals, and hope by now you would have got the grasp of AutoCAD, the basics of working around with AutoCAD. So the past week, whatever we have covered will be your most fundamental repetitive usage of AutoCAD tools. So this week, we'll look into different navigation techniques and selection techniques. So in navigation techniques, what we'll see is zoom, pan, steering wheel. So this is why we have named our session as start camera action, because we'll be using these tools to navigate around our drawing to make effective deletions and so on. Next, we have the different selection techniques. So once we have navigated to a specific portion of an object, so how to select the different instances that are interested to us. So we have the box command, fence, doubly polygon, C polygon, and additionally select commands using add or remove objects. And next also we look into some more drafting, 2D drafting fundamentals for solid and donuts. So these are again 2D objects but filled images. So we'll look into this section in detail and also look into a hands-on practice of drawing with whatever learnings we had in week 3, 2 and 1. So now let's start off with zoom functionality. So this zoom functionality is very useful for working with large drawings where you have to specify each and every dimension specifically and work on it and then move on to the next character. So towards that, AutoCAD presents the functionality called as zoom, so that you can invoke by the command C. So this is the zoom function, and so when you invoke the zoom function, you can see what are the parameters that AutoCAD allows us to perform. So first you have a dynamic zoom, wherein you can specify the corners of the window to zoom into the levels that you want, or a scale factor. And also we have additional commands, that is zoom to all, or zoom based on a center, or have a dynamic zoom, zoom to the extents of the drawing, roll back to previous zooms, scaling the zoom, or zoom to the entire window, or zoom to a particular object. So let us see each and every functionality in detail. So towards that, let us construct a drawing first. So let us come out of the zoom command. So let us just construct a simple rectangular plate of dimensions 200 cross 300, okay, with 4 M8 holes drilled across the corners, and this rectangular block is going to have 5 mm fillet on the edges. So this is the component that we need to draw currently. So before starting off, always do remember, you specify your units of operation as well as the limits of the operational page. So for specifying the limits of the paper, just let's quickly review what are the different paper sizes that are available for us to use. So you might have heard about the A4 paper size that we'll be typically using in the printing areas and for our regular use. So using that, we'll build on the other paper sizes. We have A3, A2 that have been predominantly used in the industries, and also we have A1, A0 sizes for specific requirements. So let us quickly look into how it is construed based on unfolding the A4 paper. Okay, so towards that, let us quickly draw a rectangle to drive that point. So let me just quickly go through the dimensions initially and then later come back again showing what are the individual dimensions so that you can make a note on. So first let us draw an A4 size. So we'll use the rectangle command to randomly specify a point. So as you could see now, I've taken away the command prompt for faster access. You can enable it on or off by using the hotkey Control plus 9. Okay, so using this, because sometimes it might delay the processing of your the graphical cursor movement. So towards that, you can turn it off by using Control plus 9. Okay, so now let us quickly draw a rectangle and specify a random point here, and the other point, let us use the rectangular coordinate system, relative coordinate systems, at the rate of 297 as the width and 210 as the height. Okay, so this is construed as your typical A4 paper. So now it is in the landscape view. So let us construct the A3 paper. That is, imagine that you are unfolding the paper on the breadth side. So as you can see, this is your breadth, right? So 297 mm is the width of it. So we are unfolding it in that dimension. So we'll pick up the rectangle command again with the same starting point as here, and here now we are unfolding on the width side, so let us specify the same 297 as the width and then put on comma. And so typically you are unfolding on the height of it, so you, that is, this will get multiplied twice, right? So your 210 mm of your A4 width will get multiplied twice, so you'll be getting a 420 mm. This is where we'll be using a zoom functionality. So let us quickly, use the command zoom all functionality. So I'm invoking the zoom command by Z, and then now I'm using A to specify all. Okay, sir. Now the screen window has been resized to make visible the entire object in place. So now this is the A3 paper that you can see here by unfolding a A4. So typically it means that placing two A4 sheets side by side along its breadth will give you an A3 paper. So now let's repeat the same step for an A2 size. So in A2 what you do is you unfold it in this manner, right? So you just keep on unfolding. So you are unfolding like this onto the breadth, and again you unfold along the breadth. So always you unfold along the breadth of the paper. So now let us specify one more rectangle with the same starting point as here. And now if you could recollect, the width of the A3 paper was 420 mm. So we'll specify the width, but remember now we are unfolding on the breadth side. So the breadth is 297 mm. So what we have specified here. So as we are multiplying on that, see, you are multiplying on the width of it. So 297 cross 2 is your height. So and then retaining the same breadth. So see, we are retaining the breadth of this paper as 420, whereas we are unfolding based on this length. So this length was 297 mm for us. So now what we have got is, we have got the A2 paper by unfolding an A3, and before that we got an A4. So now let us proceed to get an A1 by unfolding the A2 along its breadth here. So let us repeat the command of rectangle and with the same starting point. As you could recollect, we are unfolding the A2 paper along its breadth, so that breadth is going to be 594 mm. So at the rate of 594 cross, and we are multiplying the width of it. So what we got was earlier 420 mm of A2, so that would be 840 mm. And here typically you have got the unfolding here, you have got the A1 size. So I have now used the scroll up and scroll down of the mouse to demonstrate the application here. And now let us unfold this A1 along with the width here to get the A0 size. So starting from this point, okay, and the next is multiplying 594 the width by twice, so we'll be getting 1188, and the width to be 840, the same as the A8. So this is how you have got the overall object. So now we can see typical bits of it. So this the extended area of this page is your A0 size. So typically if you're drawing a component based, suppose let us draw a rectangle here to just to get the perspective. So what we have spoken about earlier was the rectangle of 200 mm and 300 mm. Okay, let us keep it as 200 mm and 300 mm rectangular plate. Okay, so with this is your, so typically if you're going to draw this, so you can't position this object into your A4 size. So at max you can maybe try and squeeze it to your A3, but remember you have to place your annotations, the dimensions, the title sections and all those informations into your page. So based on your paper size is where you have to determine what the drawing that you are using. Suppose if you want to position this object into your A4 size itself, it's within those limits, then you have to apply your scale command that we'll be looking into later. So this is the importance of specifying the dimensions of the workspace that you're going to work around, so that later when you take a printout message or something, then it will be easier for you to position it and then take it in the correct zoom option. So this is why we keep on emphasizing and saying that you always need to specify the limits of the working space that you are working on. Okay, so this is a brief on utilizing the limits. So let us quickly delete them all. Okay, and let us get back to the task in hand to specify the limits. Exactly, yeah. So we have to specify the limits of the pages. So let us start with 0 and 0, and typically most of the drawings will be of the A2 size, so those will be 594 cross 420 mm in dimensions. Okay, so now the limits have been set, and to also to confirm the units that they are in millimeter, yes, they are in millimeters, right? So after ensuring your limits and the units, let us start with the task. So let us draw a rectangle and specifying the point as in here. So let us say, let us start with here, some random point. So the width is going to be 400 mm and the height is going to be 200 mm. So with this rectangle plate, now we have construed the rectangle, and next task is to fillet these rectangles around. Okay, so one way of doing is using the fillet command inside the rectangle that we have seen earlier. So we have to do that, but before that let us try and draw the M8 holes that we intend to position it. So towards that, we understand that we have to zoom into this page. So let us now look into the various zoom options. So let me invoke the command prompt here to have an idea like what are the different zoom options that are available to us. So clicking on Z to invoke zoom. Yes. So right now we have different options such as all, center, dynamic extents, and let's look at one on one. So this all extents will zoom to the entire drawing in the current view. So let us select the A command to see how zoom all invokes in the current view. So you could see all zooms to the grid limits or the current extents. It zooms to the entire extent. So typically it means that the extent that we have specified is of the A2 size, that of 594 and 420 mm. So typically in that manner, this is the A2 size that is available for us with a length of 594 mm and 420, and of that our drawing has been placed in this position. So this is how the zoom all can give a bird's eye perspective of where your drawing is, and it also shows whether if it's apply if the object is outside the grid limit also, then it can show and extend like where our object is positioned. So this is one quick way to zoom out and view the drawing as in a whole, this all command. So now the next zoom command is the center option. So right now what we are speaking about is we have to draw M8 holes into the plate. So the object in hand is the rectangle. So we'll use the C command to invoke the center, and it will ask for the center point of this. So let me quickly disable this command prompt to zoom and specifying the center, and center we have to zoom in this way. So I'm clicking the dynamically selecting the center point. Once I've clicked in the center point, the next requirement is to specify the magnification rate. So typically the height that we're going to do demonstrates the limit of magnification. If we specify a small value of height, the magnification will be very high because the area of the window is going to be very small. Whereas if we give a bigger dimension, the area is going to be larger and hence the magnification is going to be small. Let us look into closely each and one. So let us say specify a magnification of size 5. So imagine you're zooming onto a 5 mm or 5 unit width of the screen. So you're zooming into the object of height 5. So as you can see, it has gone inside the object now. Maybe so that's why you have to select your magnification height as required. So we roll back using the Ctrl Z option for the undo. So now let us repeat the same zoom command with center option with a larger magnification height. So let us give the height as 500. So that means 500 mm is going to be the width. If you remember, the width of the page that we are currently having is 594 mm, the limits. So if I click on the 500 mm, say the height or the width of the window is being specified as 500 and the zoom is done accordingly. So based on the requirement, you can specify to the object in hand, and with the height of zoom, you can zoom in or zoom out based on the application. So this is the zoom to center option. So next we have the dynamic zoom option. You can see it here. So now what this dynamic does is it allows us to specify the zoom window using a rectangular view box. When we move around the cursor, you can see the view box moves around and allows us to select which is the view that we are required to see. And we can also, extend or zoom in or zoom out of the requirement window. So the rendering is slow, so I'm turning it off in the command prompt. Yeah, so specifying zoom and specifying the dynamic control. So what we can do is, in order to change the size of the view box, we can click on the screen to modify the length of it. So once we have frozen what is the view requirement, then we can click back on the screen to allow the pan of the window. So suppose if we want to have a zoom window of small size and looking particularly only on this corner study, then we can position it here and then click on enter to zoom onto that scope. So this is the facility of dynamic zoom, where we need not specify the exact dimensions of zoom window that we require to do. So this is the option of a dynamic window. So next, the command is the zoom to extends. So we'll try it out directly within here. So it means that it will zoom to the largest possible extent that is available with the objects. So now as you can see, we have zoomed to one of the corner of the object. So now let us invoke the zoom to extent. So it is invoked by starting by typing the letter E as the first one. So once you click on E, so now the zoom has been affected to the extent of this current object that we have in hand. Suppose if our drawing is really small within the existing limit of the paper, then we have an enlarging effect, that is the object fills the screen. Suppose if the object itself is of a bigger size and that it occupies the limits of the page, then maybe it doesn't have the intended zoom that we look into. So then maybe we have to go into other options. So let me repeat. This zoom to extent typically zooms to the outermost portion of the drawing. So as recalling, the limits of the paper is the limit of your extension that is possible. If the object is small, then you will be getting a zoom to the object. Suppose if the object itself is filling to the screen, maybe you won't get the intended zoom that you require. Then you have to move out to other zoom commands. Earlier what we have seen as a dynamic zoom to a specific subsection of the object or other commands. So this is the zoom to the extents command. So next we have the zoom to the previous view options. So we can roll back to 10 different zoom options that we have invoked earlier. So this is different from an undo command. Undo typically rolls back the action that you have done. So it might be say a drawing action or a deleting action also, but this zoom to the previous restore only the zooming actions or viewing actions. So that is invoked again by selecting Z and invoking the P command for previous. So when we first click on that, it will go to the previous zoom that we have included. That is what's the zoom to the extents. So likewise, you can repeat this to the latest zooms that we have invoked. So this is about the zoom using the previous commands. So next what we have is the scale command, that is zoom to the object based on the scale that is required. Let me hide that. Okay, so now zoom and specifying the scale command using S, and so it asks for the scale factor. As you can see, the scale is mentioned by the alphabet N followed by an X or an XP. So X means the number of times the scale has to be invoked. Suppose if you are giving a factor of say 2x, then the zoom is invoked 2 times for the object and the current position. For example, let us see if we given 2x for the given object and given previous view, it zooms twice into the screen for the object to locate. So let us go back to the previous zoom by invoking P command, and now let us repeat it with the scale command, yes command again, and now let us see what NXP does. NXP is that scaling times to the paper space units. So let us repeat the same command to have a view of it to XP. So based on the paper space that is available, it is doing so. Typically, maybe now we may not be able to see the difference, but which different layouts that we are using and different for each paper space by defining the different dimensions, then we can specify the option of the scale relative to the grid of that paper space. So typically we might not be using this. Our normal scale command itself can be taken, but if there are specific requirements for different paper spaces, then you can use this scale to paper option. So next zoom command what we have is, so zoom to window specifies against a rectangular corner wherein we can specify the room. So it's typical to the dynamic zoom, except here instead of a prefix zoom window and the dimensions, you directly specify the zoom area by specifying the limits of the screen. So this is zoom to window option. Next what we have is the zoom to the object command. So now we can zoom to a separate object that we have. For example, okay, so towards this let us zoom back to the extents. Okay, so now let us construct a circle, that is the M8 hole. This point, the x-axis is going to be 50 times, but y it's going to be at -50, and the diameter, let us specify the diameter and at 8. So we have the M8 hole here, right? So okay, now I had used the scroll option of the mouse, but let us say that we want to zoom to the specific object of this hole, then we can use the zoom to object command O. So now it asks for the what are the objects that are being selected to look into the maximum zoom that is available. So let us click on this object, and to complete the command let us click on enter. Zoom object. So now the object has been selected, the emit hole, and now when clicked on enter, the zoom is gone to the maximum most possible zoom that is possible with that object in the extent available. So this is the zoom object command. So now let us roll back to the overall extents of this object, zoom extent. Now let us finally look into one more zoom command called as the real-time zoom. So that typically saves as the default option that is available, as you can see highlighted here as real-time. So typically what it does is you can invoke it by pressing the enter command. So once it's done, you can see the cursor has changed to a lens view. So by left clicking the mouse and moving vertically up, you can see it zooms into the drawing, whereas you move vertically down, then it goes to the outwards zoom out direction. So based on that, you can zoom to the object in hand. Right. So, and in order to come out of the command, then you can click on the escape option. So one more point is that, as you can see, when we are zooming using the real-time zoom, we can see that we have come out of the object that was available. So in order to quickly roll back to the required space, what we can do is you can click on again zoom and then click on extend to go to the object in hand. So this is what the full application of the zoom command is used to quickly move around the workspace as well as move around the objects in hand to have a quick and fast editing. So this is about the zoom command. So now we have seen what are the different zoom commands and how it can help us through the command prompt. So now let us see like how we can invoke using the other different commands that are available to us. So first is you can invoke through the regular view. So you can click on the zoom command here in the regular menu bar in view, and then you can select the zoom as real time, previous window and all other options. So but in the ribbon view, so this is of different requirements, that is to select what are the view menus that are required. So this is not in the ribbon but in the menu bar, view menu. So this is one way of invoking view and zoom command, and typically you also have the navigation bar that is available here. So there again you can see the typical used command of zoom is either the extent or which is required to you frequently, then you can select it. For example, if you want to always zoom to a specific object, that you can click on this so that it will be always available upfront for you to select it. So likewise, whichever is required, you can select it and that becomes as a regular command here. So this is the zoom option from the GUI navigation bar that is available here. So until now we have seen what are the different uses of the zoom command. So now let us look into the other command, that is panning. Panning means that moving around the workspace with the same zoom limits but to a different object in focus. So to invoke that, let us take a different zoom as a real-time zoom. Okay, so let us say we are here. Now we have to maintain the same zoom but pan out to a different location. So the command is P for pan. So once you click on that, you'll get a hand icon. So when you click on the left button, so you can see the page has been held, and now you can move it across to go to the view that you are interested in to work on. So this is the pan option. So pan again can be accessed through the navigation bar here, the pan here, or alternatively in the view bar you can select pan from this object. So one more thing of doing is normally you can also invoke the requirement by clicking on right click, where you can see pan and zoom is also typically listed out in the normal action menus. So these are the different ways of invoking zoom and pan command. So typically why we are using these commands is to ensure that the viewing space focuses on the current object of working. So what earlier we have seen is we can also do away with this command line using Control plus 9 menu, so that we can still have that view area in scope. So likewise, we can also enlarge the graphical area. So typically this is our graphical area that we are working on. We can enlarge it by using an option called as a clean screen. So that will remove the other objects, that is the toolbars, taskbar, so that you can have more operating space. This is one tip that you can use to work on, because once you are familiar with the AutoCAD menus, then the prime mode of operation will be through command lines only. So as you are very familiar with the shortcut keys and the invoking commands, you won't be requiring the command prompt because you already have the dynamic input option enabled. So that will help you to work in the graphical screen itself. So likewise, you can take away the toolbars also by using the clean screen command, that is Control plus 0. So Control plus 9 works on the command line. So Control plus 0 removes of the toolbars and the taskbar option to provide more space. So this will be helpful in the later stages of your operation, where you work with only what is absolutely essential, because by also eliminating these, your computation speed, that is your rendering speed, will also get drastically improved. So suppose you are working on a low-end PC wherein you are limited by the RAM capacity and you have to render a large object, then you can do away with certain screen occupying parameters like what we have seen to fasten the reaction time. So this is one tip that you can look into.